Have you ever used Linux? If not, what about an ATM machine? If the answer is still no, then how about Android or iOS phones? Or have you ever accessed the internet or used Ubuntu or any Linux or Unix-like operating system? If you're watching this video, I will take it as a yes, and you must be thankful to the Linux kernel because it is what has made all these communications possible. Now let's assume you already know that Linux is just another operating system like Windows operating system or Mac operating system, with the exception that in Linux you mostly deal with a command line interface or CLI and terminal to perform actions, unlike the fancy icons and graphics of Windows and Mac OS, and you already know what Linux is. Before diving deeply into the topic, let me explain what the kernel is. To make it simple, let's explain with a basic analogy. Imagine you want to meet the president of France, but he's staying in a highly secured hotel. You don't speak French and you're not allowed to walk straight into the president's room. So first, you go to the receptionist on the first floor. The receptionist understands your language and knows what you want, but the receptionist cannot contact the president direct. Instead, they contact a trusted interpreter and security officer. The interpreter translates your request into a language the president understands, checks if it's allowed, and asks for approval. Only after approval does the president take action. Now, in your computer, your terminal and application live in user space. They understand you, but they cannot directly access the CPU or hardware. The kernel acts like the trusted interpreter and security officer, translating requests, enforcing rules, and safely communicating with hardware. So the kernel is the core software that makes interaction between application and hardware possible, safely and securely. A computer system consists of different ranks and privileges. User space is where applications, shells, graphical user interface, and containers live. And as a user, we can only interact with this level. In our analogy, the receptionist is like the user space. Both of you understand each other, but to reach the kernel, you dive deeper. There are different privilege levels in a computer system. A user space is in ring 3, where the user could interact with the system, and kernel is working in deeper level of ring 0. As for the rings 1 and 2, they are rarely used nowadays, and they are also out of scope for this topic. Now, how the kernel works internally. As already mentioned, all the programs like applications, shells, graphical user interface, and containers run in user space or in ring 3 or user mode, which means they cannot access hardware directly, they cannot control memory freely, and they cannot execute privileged CPU instructions. And this is for safety. So when a program needs something serious like reading a file, writing to disk, allocating memory, or creating a process, it makes a system call, which is just like a formal request to the kernel. Examples of system calls could be read, write, open, fork, and so on. Once a system call happens, the CPU switches from user mode to kernel mode, which the switch is controlled and safe, and the application never gets direct power, which is enforced by the hardware itself. After switching to kernel mode, the kernel validates the request, which at this stage it acts like a judge. It checks if the request is allowed, does the process have permissions, is the resource available, and will this harm the system or not. If allowed, kernel proceeds. If denied, request is getting rejected. Depending on the request, the kernel may schedule CPU time, allocate memory, read or write disk, send packets through network drivers, and talk to the device drivers. And just to keep in mind, only the kernel talks to hardware, and then the kernel returns the result. At this stage, CPU switches back to user mode and the application continues execution. And if you're wondering that it is a long process, let me tell you that this happens millions of times per second. So speed is not the issue. Here, you could have a look into the visual flow of the concept to understand it better. And it's worth mentioning that while handling requests, the kernel is always managing process scheduling, memory, file systems, networking, and security. Just to sum it up, the kernel listens to the requests from applications, safely talks to hardware, and returns results, all while protecting the system. Now moving to the Linux kernel, it was first created in 1991 by by Linus Torvalds. It was initially started as a small personal project like many dangerous ideas does, and now it is developed by thousands of developers worldwide. And what I mean by developers worldwide is because unlike Windows and Mac, Linux is open source, which means that anyone can study, improve and use it. That's how it runs everywhere, in servers, supercomputers, phones, routers, ATMs, cloud platforms and more. And because of being open source, Linux evolves faster, adapts better and trusted by developers and companies. Now the last point I want to mention is the Linux kernel's modules. One of the reasons that Linux is so flexible, fast and reliable is because of its module system. To explain what Linux kernel modules is, let me explain that. The Linux kernel is like a big program with tons of features, but it doesn't need everything loaded at all times. Think of it like a hotel. Not all rooms are open. When a guest arrives, the hotels open a room. When they leave, it closes the room to save energy. Kernel modules are these rooms and follow the same logic. A good example of this could be plugging a USB drive into your computer that will automatically load USB storage module, and when USB drive is detached, it will automatically unload USB storage module to save storage and boost performance, which is why modules load is on demand, because it keeps memory free and system efficient. Now you might ask if the module concept also exists on Windows and Mac operating systems. The answer is yes, but sort of, because they are more restrictive and cannot be dynamically added or removed as freely. In summary, if the Linux operating system is a body, the kernel is the brain controlling everything. Kernel is the mastermind behind all interactions between software and hardware. Now, if you like the video, subscribe for more.